Welcome to today's mathematics class, and today we'll be talking about angles on parallel lines. Two lines are parallel if they do not meet and can never meet or intersect when their length is increased. And for any angles to be formed on a pair of parallel lines, there must be a line cutting across them, and it is called transversal. Parallel lines are represented by arrow notation to distinguish them from intersecting lines. If we are to represent these two parallel lines with an arrow notation and a third line coursing through them, which we call transversal. So, for angles to be formed on a pair of parallel lines, there must be a transversal cutting across them. And the angle here now be A, B, C, and D. Here will be E, F, G, and H. And for us to calculate angles on parallel lines, there are 5 major angles that we must consider. Firstly is the corresponding angles. And what is corresponding angles? These are angles that are in the same relative position on two lines that are intersected with a third line called transversal, and they are equal. Let's consider the first angle, which is corresponding angle. From this pair of parallel lines and the transversal, we have B is in relative position to F, therefore B is equal to F. A is in relative position to E, therefore A is equal to E. While C is in relative position to G, therefore C is equals to G. And D is in relative position to H, therefore D is equal to H. These are the corresponding angles on this pair of parallel lines and transversal. So let's consider the second angles, which is vertical opposite angles. These are angles that are opposite to each other at a point where two lines intersect and they are equal. If you look at this now, A is in opposite to D. Therefore, B is also in opposite to C. So, A is equal to D and B is equal to C. So, E is equal to H and F is equal to G. If we are to bring them out, vertical opposite angles, we have B is equal to C, A is equal to D, E is equal to H, and F is equal to G. Let's consider the third one, which is alternative angles. These are angles that are in opposite sides of a transversal within a parallel line, and they are equal. If you look at this now, C is in opposite side to F on the transverse line within the parallel lines, and C is equal to F, so is D equal to E. If we are to bring it out, alternative angles, we have C equal to F and D equal to E. These are the alternative angles on this pair of parallel lines and this transversal. Let's consider the fourth one, which is angle in a straight line. Angle in a straight line. Angle in a straight line is when two lines intersect to form a straight line. The angle formed at that point of intersection is equal to 180 degrees. That is, their sum is equal to 180 degrees. So, A and B is angle in a straight line equal to 180 degrees. C and D is also angle in a straight line is equal to 180 degrees. E and F is also angle in a straight line and is equal to 180 degrees. So is G and F, A and C, B and D, E and G, and F and G. These are angles in a straight line. Let's consider the fifth angle, which is angle at a point. The angle at a point is also known as angle at a vertex. Is the angle formed by two lines or rays that intersect at a single point called the vertex, and the sum of all the angles at that point is equal to 360 degrees. If you look at this diagram, here is a vertex and the sum of this vertex is equal to 360 degrees. So it's also this point and the sum is also equal to 360 degrees. The fifth one, which is angle at a point, A plus B plus C plus D is equal to 360 degrees. Therefore, E plus F plus G plus H is also equal to 360 degrees. With these 5 major angles, we can calculate any question on angles on a parallel line. So let's consider question 1. Let's consider this question 1. If you look at the diagram, we have two different parallel lines. These two pairs and one parallel line, and they are represented by two arrowheads, while this and this is also a pair of parallel lines, and they are represented by one arrow notation. So when you look at the question, we are asked to find S, Y, and Z. And earlier we said that we have 5 major angles that are used in calculating angles on a parallel, and they can only be formed where there is an intersecting line. We call it transversal. And if you look at this parallel line is acting as a transversal to this pair of parallel lines. This other pair of parallel lines, this parallel line is also acting as a transversal to this pair of parallel lines. And parallel line can be extended. You can extend it. You don't need to be afraid to extend it. So you can extend it. For example, if you are to extend it upward, we see that this is a transversal to this parallel line. And we said that for a corresponding angles, to find S now, a corresponding angles is the angle that are in the same relative position on two lines that are intersected with a third line. And if you look at this, S and 20 degrees are in the same relative position. S will now be equal to 20 degrees. S is equal to 20 degrees. That is corresponding angle. S is equal to 20 degrees. And for us to find Y, you will notice that this line is not a parallel line, but is a transverse line. but there is no other parallel line that this line is cutting across. If you look at this parallel line, we can also extend it, but for this intersecting line, we cannot extend it. So for here, we can draw a line that is parallel to both this line and this line. Let's draw this parallel line. This is our third parallel line. And if you have to consider this angle with this angle, this will be alternative to this angle. Since alternative angles are angles that are in opposite side of a transverse line within two parallel lines, y will now be equal to this angle. And we have already gotten our s to be 20 degrees. S is also alternative to this angle. And from here to here, we said that S is equal to 20 degrees. So here will be 20 degrees. And if we minus 60 degrees from 20 degrees, we have 40 degrees. Since the angle in this place is equal to 60 degrees. Because when you sum 20 and 40 together, we have 60 degrees. So y will now be equal to 40 degrees. Y is equal to 40 degrees. That is alternative angle. For us to find our z, we can use angle in a straight line, because when two lines intersect to form a straight line, the angle formed at that point of intersection is equal to 180 degrees. That is, their sum is equal to 180 degrees. So z plus 20 degrees will be equal to 180. That is angle in a straight line. When you make z the subject of the formula, we will have z is equal to 180 minus 20 degrees. 180 minus 20 degrees, we have 160 degrees. This is our answer to this question. Let's consider question 2.